I didn't think I'd get applause before saying anything. I should just leave and be done with it. So hi, everyone. I'm Justin Edelson. I'm really happy to be here. I've been involved in the Sling project for about 8 years, but this is my first time coming to adaptTo, and it's a big honor for me. So I'm a project lead on the AM engineering team, and today I'm going to be talking about Sling Models and specifically this new exporter framework. But before getting into that, I wanted to sort of step back and talk a little bit about context. So Sling Models has been in existence since 2014, so it's 3 years now. And the goal, from the beginning, has really been to reduce boilerplate code when building kind of properly layered applications. When I got involved in Sling and CQ AEM, we were really building what used to be called Model 1 applications. I don't know if people still use those terms, but where you just had a big JSP and there's a bunch of code in there and it worked. Or an ECMAScript file, as the case may be. And over time, I think we all came to the realization as a community that we needed to layer our applications and have real model objects and more of a Model 2 kind of architecture. So in 2014, the focus of Sling Models was really all about reducing boilerplate code for adapter factories. So take code that would take a resource or a request object and turn that into a strongly typed domain class. For example, when I first gave a talk 3 years ago in London about Sling Models, there was an example. It was a very simple model class that showed that there were something like 72 lines of code in the traditional way of having an adapter factory that would get the value map and call a bunch of setters, and then moving that to Sling Models brought it down to 13 or 14 lines of code. So a pretty good reduction in the boilerplate. So since 2014, the Sling Models framework has evolved in a few ways. So in that initial talk, I laid out kind of a roadmap for what I thought was the 6 months, a year ahead. Took a little bit longer than that. That's cool. So the first thing was more standard injectors, and we got that. We have the self injector, which is fairly trivial, and then the Sling object injector for things like the resource resolver and other Sling domain classes. I wanted to do more AEM-specific open source injectors in a project that I run that some of you may be familiar with called ACS AM Commons. And I didn't do this, but Matthias Schroger, who I don't know is here, and Konrad Vilnius, who definitely isn't here because he's on paternity leave, did this, and that's super great. And then there's an annotation in Sling Models that was pretty hastily thrown together, if I'm being honest, called @via, which was to, if you have a request object and you want something derived from that, you put @via on it, and you can get the resource. And I had this idea in 2014 that was really step one, and that we would need other types of ways of getting from object A to object B, and we did that, but just like in the last 6 months. And Vlad and Burkhard this afternoon are going to talk about that in a broader context. They're not going to spend 45 minutes talking about this one thing. But that turned out to be really important for some things in the AEM core components. So what didn't I think was going to happen, or what I hadn't really thought through, and Dominic said that in this part of Germany, if I put God on the slide, you all would make fun of me because that's like a southern German thing. But this is an expression in English, right? We say if you want to make God laugh, make a plan, and that's true of roadmaps, right? You want to make anybody laugh, you say, here's my product roadmap. So here are all the things that weren't on that roadmap in 2014. So injector-specific annotations, an actual model factory, so a class service interface that you use instead of using adaptTo. Not that there's anything wrong with adaptTo, is the name of this conference. Sling validation integration, alternate adapter classes, which was something Stefan did. Actually, I think half of these things Stefan did. The BND plugin, and then the exporter framework, which is what I'm going to talk about today. So the exporter framework is very much along the same lines of reducing boilerplate in two specific domains. The first is format conversion, so going from a strongly typed Java object into some serialization form or some other object form. And then content access servlets, where you have a servlet and you need access to the content, but in some specific format. And these two things are obviously very well linked together. Now, from a design perspective, the exporter framework assumes that there's actually a lot of libraries in the broader Java ecosystem that can do this format conversion logic. Although it's certainly possible to write your own completely bespoke exporter implementation, the idea is that most of this already exists. And so in Sling specifically, we have an implementation with the Jackson library. But what I'm going to show in the slides is how that could be done for other libraries like JSON or JacksB. So the Jackson one that we have is really just, like, in a sense, a reference implementation, but was never intended by me, at least, to be the end of the line. The use cases that we target are really these two things. So again, you have an external application where you need content from Sling, and yes, you can today very easily use the standard GET servlet and get that JSON response or the XML response. But what I've experienced and what I think many people have experienced is that for lots of applications, you need a more specific response, either one that's predetermined, say by some front-end framework, or where you need to, just to sort of key off of some of the stuff that Bertrand was talking about, where you need to aggregate multiple content sources. And it's not just the properties of the current resource, but maybe it's resources from over here and over there and some third-party system, pulling that all together. And the second one was around a trend that we see around isomorphic rendering. So wanting to have the same or similar model class structure used on both the client and server side. And obviously this is really popular in the JavaScript world and Node.js and things like React isomorphic rendering. But I think there's a strong case to be made that we can do this in Java, not necessarily by having the same code run on the client and the server side, which we can't really do, but we can have the same model, the same class definition, just exposed in different ways. So there's a Java implementation and then a JavaScript implementation of that. But they use the same concepts. So to look at a really simple example, today, if you want to handle a request like this to get some resource in some specific way, again, not the regular GET response, what do you have to do? One way of doing that is what I have here. You have the request, you adapt it to some model object, maybe you use Sling Models for that, maybe you don't. Then you transform that model object into a string, and then you serve that string to the client. There's probably 6 or 7 other ways of doing that. You could do direct serialization, you could serialize it to you could transform it to a model object and then use like a streaming JSON library. But this is, let's look at this one example because it happens to work really well for the exporter. So with the Sling Models exporter, you do all this same stuff, but without writing any code, just by adding some annotations. And Sling Models will handle those same 3 steps for you. It'll take the resource or the request, adapt it to your model object, transform the model object into a string, and then serve that up to the client. And the way you do that is by really adding 2 annotations, or 1 annotation, 1 attribute. So you have the app-model annotation already, and we added a new attribute for this called resource type. And that's how you associate this specific model class with 1 or more resource types. So when the servlet comes in, it knows that this is the model object to use. And then you add this @exporter annotation, which says, sort of in reverse order, when this extension is called for the resource type in the app-model annotation, call the, in this case, the Jackson exporter, give me the string, serve that up to the client. There's another attribute that I'm not showing here called selector, which lets you change the selector. It defaults to model, but you can provide a different selector if you want. And the last step here is any of these serialization frameworks are going to have their own kind of default mechanism, generally based on Java bean conventions, for doing the serialization and the transformation. But there are ways to tweak that and say, this property is called property, but I want it to be called some property. And to do that in a layer above the actual class. So this is how it works. Hopefully this is legible from the back. So the request comes in for the resource, and we're trying to actually set the stage really nicely and showed all that stuff so I don't have to talk about it again. But the request comes in, says get my content, my resource. That is handed off to the exporter servlet that's been automatically registered based on those annotations. The exporter servlet does the adaptation to the specific model class. Then it calls the named exporter, in the case I gave earlier, the Jackson exporter, but it could be a custom exporter, and then serves that back to the client down here. And in all of this, the only code that the developer is really responsible for is that Sling model up at the top. What's shown on the left side here that's sort of grayed out is how that same model class can be used from an HTML script or a JSP or whatever kind of scripting you want to do. So we're sharing the model here. This is not quite isomorphic rendering, but quite close, where we're using the same model class in the HTML script as well as serving up the JSON to the client side. So one interesting question that I get since this has been introduced is about kind of complex object graphs. So it's pretty straightforward. If you have only one model, you put the export annotation on the one model, everybody's happy. But in a more complicated case where you have the parent and the child, so the child could represent a sub-resource or just, again, some arbitrary data structure, where do you need the exporter? The answer is that you really only need it on the parent component. The exporter defines the entry point for the HTTP request. If you think of the exporter annotation as being the same thing as registering a servlet, which is essentially what it's doing, I don't want to necessarily have child component exposed as an HTTP endpoint, just the parent component. And it's worth noting that although I'm talking here about access through the HTTP servlet, in fact, the framework itself supports really any kind of transformation. We, again, are really generally talking about to-string annotation conversions, but the API supports any kind of transformation that you want to do. So, for example, Jackson natively supports converting a model object into a map. So that just works. For JacksB, you could imagine something where we're taking a model object and transforming it into a DOM document or some other class along those lines. So this is more kind of trivia. Isn't used that much, but certainly is useful. And if you need multiple exporters, so if you have your custom exporter, this would come into play. Here I have a different selector, but the same extension defined to do JSON. So I don't like how Jackson works all the time, but some of my clients depend upon it. Maybe I want to expose a different endpoint and use JSON serialization. Someday we'll move everything to Java 8 and everybody will be happy, and we'll use @repeatable and you don't need this @exporters annotation, but we're not there yet. Someday. Maybe then Java 10 will have been released. I guess they're going to be now on a quarterly cycle, so it'll be Java 35. Within the API, there's this concept of options. So we actually know this already from the get servlet, has for years, probably from the beginning, you guys tell me if I'm wrong, has this tidy option, right? So we needed some way of replicating that inside the exporter. And just supporting tidy seemed to me too simplistic. And so I came up with this idea of just a map of options, so a simple map of name-value pairs. And the exporter framework doesn't attach any semantics out of that. It's really all up to the implementation, the model exporter, the thing that's actually doing that serialization or string conversion, whether or not, for example, it wants to support tidy. All the framework does is define these 4 different ways that you can pass options in. So there's an export model API that you give it a map. You can provide them on the model classes through the exporter option annotation, and you can do selectors or request parameters. So for Jackson specifically, there's a few different types of options supported. There's tidy, and that can be tidy equals true or tidy equals any value that isn't false. And then all of the Jackson serialization and mapper features are supported. So you say serialization feature dot the name of the feature equals true or false in most cases, and that corresponds to setting this flag in the Jackson API. So just a couple examples. Jackson by default serializes dates in Java as timestamps, as opposed to like a ISO 601 format, because there aren't dates in JavaScript. So if you don't want that, you would set this serialization feature to false. And then tidy here is being set as a selector or a query parameter. Obviously, you'd only do one or the other. And these are, they're all functionally equivalent in the sense that when the exporter gets the map of options, it's all of those things combined together. Both those specified on the in the model, the selectors, and the request parameters. So I wanted to talk a bit about extension points, because again, it's really a framework that has a default implementation or a one implementation, but is meant to be extended upon, like all the things we do. So the first, and really the only extension point in the framework itself is the model exporter. So this defines a new named exporter and has these 3 very simple methods. Get name returns the name, is supported, lets you define which classes, which output classes are supported, and then the bulk of the implementation is in this export method. But again, in the vast majority of cases, the expectation is that the export method here is really glue code that's binding the exporter framework and Sling Models to some third-party library. So the Jackson exporter's export method is like 50 lines of code, most of which is just like parsing the options and figuring out what to do. So what I'm going to show here are like some really simple implementations. The real-world implementations might be a slightly more complex, but not that much. So JSON is like literally 1 line of code. You take the model, you create a new JSON object, and you say to JSON, new JSON, and then you call to JSON on it. That's it. Here, this is only supporting string. If you needed to support multiple outputs, you'd have some conditional. Bless you. Here's the JacksB example. This is really just doing string. If I was also doing the DOM integration, I'd take twice as many lines, and it wouldn't fit on the slide. But you can, if you're familiar with the JacksB API, I'm sure you can imagine what that is. So again, the bulk of it is like bootstrap code to set up the JacksB context, and then setting up the string writer and calling Marshall on it. And then you get your string. So like the bulk of the logic here is all in the library that already exists. We're not rewriting that code from scratch. The other extension point that I want to talk about is not in the Sling Models exporter framework itself, but specifically to Jackson. and that's called a JSON module provider. And this is a generic kind of concept in Jackson that allows you to customize the serialization of classes that are outside of your code base. So if you, I think they refer to this as unowned classes. If you own the classes, and again, Vlad and Burkhard will show some of this stuff later in the way that they use this. If you own the classes, then you can add the Jackson annotations or the JacksB annotations, because it also supports those, onto your code. But that isn't always practical, and sometimes you need to change the serialization of a class that isn't inside your code base. And so for that, this Jackson module provider was created, which takes a Jackson module and attaches it to the Jackson instance that's used by the Sling Models exporter. And it turned out that we actually needed this within Sling Models because when we just do regular kind of Java bean serialization, there's a number of classes that we use all the time for which the output's totally inappropriate. So if you've ever serialized a Java resource using Java bean style serialization, it's not useful output. So for that, we wanted to get something that approximated what you would get with just the get servlet. The same thing with the HTTP and Sling HTTP and regular servlet request classes. I think these actually have loops in them that, like, the request has a pointer to the response, which has a pointer to the request. So at some point, they actually end up in an endless loop there. And then weirdly, Java util enumeration, which is used by the servlet request classes, doesn't get serialized at all by Jackson by default. But there's like a third-party thing that does that. So we actually had to build this extension point to get our stuff to work correctly. And although you could argue that the resource class in Sling is owned by Sling, and the Sling HTTP servlet request is, they are outside of the Sling Models code base. And so because Sling is highly modular, we didn't want to have sort of this cross-dependency. And it also seemed like a useful extension point. So to look at a specific example, let's say that you have this model class, and here I'm ignoring the app model and exporter annotations, but you have a class that used JotaTime. Is everybody familiar, at least conceptually, with JotaTime? Okay, so it's a fancier date-time library. So here, we have a timestamp property that's going to return a date-time object. And you shouldn't be able to read this. There's a screen, so it sort of defeats the purpose. But like, this output's totally not useful. Somewhere in here is the milliseconds from January 1st, 1970. But the rest of this is not what I want. This is what Jackson does, trying to serialize that date time as a Java bean. It's not really useful. And so there's already exists this JotaTime module for Jackson. And all we need to do is create a module provider that returns it. And then that module gets added to the Jackson instance used by the Sling Models exporter. So again, very simple class. And then, ta-da, when we serialize it with the module installed, we get this timestamp, which is exactly the value we're looking for. And interestingly, if we use that serialization feature from 5 slides ago, we'll actually get the ISO 601 value instead of the timestamp. So the same serialization flags are respected in this particular case. So to sort of summarize, and this went a lot faster than I was thinking, but that's fine. To summarize, what the use case that we're targeting is all around taking model objects and converting them to some other format. So generally, that's going to be this JSON servlet. Just add annotations. What we support within the Sling project is all powered by the Jackson library. You can use this module provider for unowned classes, and other formats and other libraries can be done through the module, the model exporter SPI. that's all I had. I don't know if there are any questions. Hopefully there are. Or not? Okay.
One question?
In one of your first slides, you posted your to-do list in 2014.
Yes.
And you also said that you finished it 6 months ago. So do you already have a to-do list 2017?
I don't. I mean, at this point, so the reason I would say that it took 3 years to do that 6-month to-do list was the slowness in which Sling Models got adopted by AEM itself. If I'm being perfectly frank with everyone, a lot of the feedback that I've gotten in the last year has been from Vlad and Burkhard and the team that works on some of the AEM components. Stefan has taken care of his problems and has done a great job of contributing, I assume, the stuff that you're seeing from the Provision customer base. So as our internal Adobe customer base has grown for Sling Models, that's where a lot of that use case, a lot of those changes have been driven from for me. So I think as the core components, as a sort of second level effect, the core components get further and further adopted. I think that'll drive the types of use cases that I had identified 3 years ago. So no is the short answer. I don't know what the next 3 years bring. I'm sure it'll be interesting.
Okay, any other questions? In the front, we've got one.
Hey, it's a little bit of a curveball, admittedly. I was just wondering, is there any, or would you see any possible relation to something like GraphQL and stuff like that between the models? And if so, also maybe as follow-up, it almost seems like at least partially you could make a GraphQL thing be implemented in this thing, So if I understand it correctly, but just wondering.
So where I would see it is more as in general, you would want a GraphQL entry point. This is a curveball, but you'd want like a general purpose GraphQL entry point, and then be able to ask for, in the same way that in GraphQL you can ask for the properties, the keys to be different, I could see wanting to ask for different serialization forms at the returned object, the query result level. But I don't know that, I think if we're going to support GraphQL in Sling, which is an interesting question, but if we were going to do that, it would be, I would do it as a kind of a separate module that, similar to what the stuff I've been talking about, allows for different exit points. So one entry point across Sling, and then different exit points, one of which is the standard get serialization, one might be a model-based serialization. And because we have the ability now to tie a strongly typed Java object, a Java class, to a resource type, that would all sort of work. But I wouldn't do, you could do GraphQL in Sling Models, but I would more see it happening in a separate module. Kind of like, it's almost like the reverse of what was done for validation, where validation plugs in at the end of the process. GraphQL would plug in at the beginning.
Thank you. Any other questions? In the very back on the right
In the
side,
dark.
there's one.
Hi, I have a question regarding this parent and child example that you have shown before. You said that we have an exporter annotation on the parent class. Suppose we want to have on the exporter on the child, and that's exporting in the JacksB, and the parent somehow doing on the JSON or JSON or something. Is it possible?
Yeah, that's a great question. So, I'm going to read back the question, make sure I got it. So what you would want is to output the parent component using Jackson as JSON. And then if you access the child directly, you want it as XML using JacksB. Yeah.
Correct.
So what would happen, so you'd need the exporter annotation on both classes, because again, the exporter defines the entry point. The exporter on the parent would have Jackson, JSON, the model, the selector would still be model, and the child would be exporter named JacksB extension XML. When the parent was accessed, the child would still get serialized through Jackson, because the serialization is defined at the entry point level. When the child is accessed, it's going to use JacksB, because it's the one being accessed and it has the exporter annotation. Where things get really interesting is, let's say that the child had a reference to some third object, and the parent had a reference to the third object. You would have that third object be exported based on the entry point. So it could be either way. But yeah, that's actually a really good point, because that's implied but not stated here, is that regardless of what annotations are on the child component, the way that it's serialized depends upon the access at the parent.
Okay, thank you. Any other questions? Okay.
Okay.
Thank you very much
Thank
for
you.
your talk, Justin.